Well, hello everyone, and welcome to the latest Sporties webinar. Thanks for joining us for In-Flight Weather Fundamentals. My name is John Zimmerman. I'll be one of your hosts tonight. And should be an action-packed hour here. We are going to cover a lot of ground, starting out with some of the basics of weather, just to make sure we all understand how the basic information is assembled. Then we'll talk about some of the tools you can use for getting weather in flight. And then we'll talk about some tips for using those tools wisely. And then we'll apply that at the end with some scenarios taken from some real-life trips to put that into use. So we'll be moving through a lot of material. A couple reminders as we get started here. We will be recording this webinar, so if you have to step away or if you missed something, check out sporties.com/webinars in a couple of days and we'll have a recording up. Also, feel free to ask questions throughout the night. You should see a questions option in the lower right-hand corner of your screen there in the GoToWebinar control panel. Feel free to ask a question at any time, and we'll make sure to leave some time at the end to answer some of those questions. So without further ado, we're going to go ahead and get started. Again, my name is John Zimmerman. I'm a vice president at Sporties Pilot Shop, so I get to play with all the weather tools from Stratus to Scout to Garmin GDL series, which is great. But really, tonight I come to you more as an active pilot. I'm an ATP, fly helicopters and airplanes and anything I can get my hands on, I guess. So I've been flying in weather for over 20 years and flying with datalink weather for most of that, that we've been fortunate enough to have some type of datalink weather. And I'm joined tonight by Scott Dimmick. Scott comes from maybe the other side of things. Scott is a experienced and very well qualified meteorologist with a long history in the weather field. He's also Sporties' resident weather expert. Scott hosts the Weather Geek series in our Takeoff app. For those of you who use our Takeoff app, great series of really diving into the details on weather. So Scott's going to be talking to you tonight about some of the details and the nitty-gritty of weather and how that works. I thought I'd start out tonight just real quickly with framing why all this matters. And, pilots spend a lot of time talking about weather, and we spend a lot of money in some cases on, weather tools in the cockpit. I think it's worth thinking about whether this is just feel-good stuff or not. And I believe it's not. I believe that the smart use of weather technology, emphasis on that first word, can really improve safety. Now, it's really hard to draw a direct line here, but there's some stats I ran across recently from the AOPA Air Safety Institute that I think are at least interesting. Weather accidents are declining in general aviation. And, nothing's ever forever, but this trend appears to be fairly steady. Since about 2011, weather accidents have trended down. Now, there are all kinds of reasons for that. And we could probably list 6 here if we started. But in the face of generally steady accident rate in general aviation, maybe down slightly, but overall fairly steady over the last 10 years, weather accidents are going down. I think it's at least interesting to note that in 2011, ADS-B ADS-B weather really hit the market in a big way. And so, I'm careful about the correlation causation trap here. Don't want to get carried away, but I think it's at least interesting that that suggests maybe there's a chance here that some of the new technology is helping us fly safer. I also think it's worth pointing out, what do we mean by weather accidents? Because sometimes we can get the wrong idea. Well, the biggest one by far is VFR into IMC, so continuing visual flight into instrument meteorological conditions. So if you're a VFR pilot, the #1 way to be safer around weather is not stumble into IMC. And certainly there's a lot of tools that can help you with that. Thunderstorms are right up there, and lots of pilots worry about thunderstorms. They're up there. And icing, another one that pilots worry about. So if we just took those 3, if we avoided VFR and IMC, thunderstorms, and icing, you could cut weather accidents by over 80%. So it's at least gives us something to shoot for. That may be unrealistic that we can get those to 0, but for those of us here in the webinar, let's at least consider that maybe as a goal of taking out those 3 big weather issues. With that, I'm going to hand control of the presentation here to Scott, and he's going to dive into weather fundamentals to make sure we're all thinking about the tools that we are using here in the right way. So give us just a second for the switch here. And Scott, coming your way.
Thanks very much, John. It's an honor to be with you tonight. Thanks to everyone, over 200 people joining in the fun tonight to learn about various tools, especially weather-related tools, and how to use those to your advantage in the cockpit. As I said, it's great to be here this evening. Thank you for taking some time out of your Thursday evening to be here. I'm honored to be doing this with John, very smart, talented pilot, and someone that has been a friend, and his family has been a friend of mine for over 25 years. I've been the meteorologist with Sporty's Pilot Shop for a few years now. We'll be covering a lot of content at a fairly high level tonight, but remember, for a deeper dive, I encourage you to review the weather content in the Takeoff apps and the Sporty's Private Pilot app. The screaming message or messages for all we present tonight are: don't let the bad weather in front of you become the bad weather around you, and also recognize that technology should be used to guide your decisions and not make them for you. Let's first start with some fundamentals, understanding how radar works, then diving into satellite and getting a basic understanding of METARs, the more advanced part of METARs, and this information will come a little bit later on in the course. So let's talk about how radar works. At a very simple level, radar transmits pulses of energy and waits for them to return. So the radar will send out information and wait for it to come back. And it's all up to the radar processors to make sense of this information, because ultimately we need those radar processors to create a plot of what we call reflectivity. In other words, radar sends out a pulse of energy and it's looking to see how much of that energy returns. How much does that atmospheric target, whether it be a raindrop, hailstone, dirt, dust, how reflective is it? You might expect that higher reflectivity values indicate heavier precipitation, but that can often signal hail, including large hail, but also sleet. Basically, think of higher reflectivity as a larger target in most cases. Also worth noting, if you watch television, if you use a radar app, and you've seen a sweep go around a central point, you may be led to believe that the radar just scans at one angle, but that's not the case. National Weather Service radars and FAA radars scan at various tilts, and that allows us to see a three-dimensional view of a storm, but it also enables us to see different types of reflectivity. Let's compare base and composite reflectivity. Terms you may or may not be familiar with, but let's go through them briefly. Base reflectivity is radar imagery from a single radar and a single tilt. So technically speaking, a radar will sample the atmosphere, including storms, at various elevation angles. But going forward, when you hear the term base reflectivity, when meteorologists are talking to each other and they're talking about base reflectivity, they're usually referring to the lowest tilt. Composite reflectivity is different. Composite reflectivity is the maximum reflectivity from any elevation angle and over every point a single radar samples. So let's say there's a thunderstorm over a city. Whether the storm has higher reflectivity close to the ground or aloft is irrelevant in composite reflectivity, because the maximum reflectivity value over that city will show up in the composite image. Storms, for that reason, almost always appear stronger in composite reflectivity. And you can see the visual difference here on the left side of the screen. Storms don't look quite as intense in the base reflectivity as they do in the composite reflectivity. But if you look in the lower left-hand part of the base reflectivity image, you can see some faint blues, possibly indicating outflow boundaries, which may be a big hazard to your aircraft. Now let's take this one step farther. Mosaics are a composite of the composite reflectivity from numerous radars. So we're taking the composite image from one radar and multiple radars and looking for the maximum reflectivity value from any radar over a point to create the mosaic. Now it's worth noting, including in this picture that you see here, that some mosaic imagery that you find online or in weather apps may be cleaned up some to reduce some ground clutter or anomalous propagation. It's worth noting that may or may not allow you to see certain low-level features, such as outflow boundaries. If you're a higher altitude pilot, general rule of thumb, if you're spending more time 10,000 feet or above, you should be focused on composite reflectivity if you have the option, as it better represents a storm's vertical strength. Lower altitude pilots, 10,000 feet or below, give or take, should focus on base reflectivity because, as I mentioned, base reflectivity shows us the reflectivity closest to the ground. Now, there's a catch here. Radars do not scan at radar level, and there's also a curvature to the Earth. So once you get a few hundred nautical miles away from the radar, you're not just looking a couple hundred feet above the ground, you're looking tens to tens of thousands of feet above the ground. Now let's go into satellite imagery. Very different from radar, but still very useful for assessing the strength of areas of low and high pressure. Visible imagery is a view of the Earth in the visible light spectrum. Think of it as you being strapped to a satellite looking down at the Earth. As you might expect, when it gets dark, you're not going to be able to use visible imagery. Infrared imagery shows the temperature of the objects it samples. Brighter is usually colder. Some infrared imagery, like the one you see here at the right, is color enhanced. So brighter here indicates yellow, oranges. Those indicate colder cloud tops. Now, infrared imagery can also sample really cold air masses. So be on the lookout for something that may look like a cloud as a continental polar air mass comes in from Canada. Water vapor imagery looks at water vapor between 15 and 45,000 feet above the ground, approximately. Dry air is usually darker. Moisture-laden air is usually white. If you use a product like ForeFlight, you're looking at infrared imagery. I'm only showing you the three different types of satellite imagery because you may see visible or water vapor imagery online or elsewhere in your briefing. Let's also talk a little bit about METARs, and we'll take a deeper dive on this a little bit later on. If you've gone through the private pilot course, we've broken down specifically how to read a METAR, but as a general rule of thumb, where, when, wind is what you start with. So you have the identifier. The where indicates the date of the observation, then Zulu time. When is covered there, and then the wind part, degrees, and then wind speeds. Gusts may be included as well. Beyond that, METARs are a little different. You'll typically get a visibility. You'll typically get precipitation if it is reported. You'll typically get cloud bases, temperatures, altimeter settings. We'll also spend some time a little bit later on in this presentation discussing peak winds, wind shifts, things that happen beyond the remarks. METARs, simply put, are surface reports that give you ground truth verification on conditions at airports. And as we mentioned, where, when, and wind will always be there in the METAR. Usually visibility, obscurations, precipitation, cloud base information, temperatures, altimeter information will follow. But you have to be careful. Mostly automated reports are coming when you're looking at a METAR, and the information quality will vary. We have ASOS systems and AWOS systems, or automated surface observing systems, automated weather observing systems, respectively. And there are limitations on what those automated devices can sample. Surface-based weather systems like AWOSs only report cloud bases up to about 12,000 feet. That's above the ground level. And even observers at major airports that have the power to augment an observation will typically not include clouds with a base of 30,000 feet or higher above ground level in METARs. So know that there are limitations on what you can learn from a METAR, but this is just one piece in a puzzle that will allow you to make better weather decisions and ultimately keep you more informed during your flight. We're now going to move on to SiriusXM and ADS-B with John. So I will be passing the torch back over to him.
All right, thanks, Scott. and hopefully everybody's got my screen up there after the pass there. So Scott laid a real good foundation there for what weather products we're looking at, whether it's radar, satellite, or METARs. Now we're going to talk about sort of the pipe, how we get those weather products into the cockpit. And so we're going to talk real briefly just about ADS-B and SiriusXM. Those are the two real ways you can get it in the cockpit these days. We're not going to go into excruciating detail here, but I want to give you an understanding of kind of how the two different systems work, what are the pros and cons, what are some of the options, and then we'll start to apply this stuff. So we'll start with ADS-B. Hopefully many of you who have been reading an AOPA magazine the last 5 years know ADS-B. This is part of the FAA's Next Gen airspace development program, and we're not going to get into all that stuff in the mandate and the avionics there. The part we're talking about today is the free weather that you can receive on ADS-B in. So this is a data link system. Weather is transmitted from a network of ground stations all throughout the U.S. And that's the key piece with ADS-B. It's ground-based, so it's coming up from the ground like VORs. So just like a VOR, line of sight reception is what we're talking about here. So you need to be at altitude to get reception most places. Unless you're at an airport where there is literally an ADS-B ground station on the airport, you probably won't have ADS-B weather on the ground. Now, fortunately, coverage has gotten a lot better, so you don't have to be thousands of feet in the air. You can see this map here is coverage at 1,500 feet AGL. So many places, especially east of the Mississippi and up and down the West Coast, you'll have ADS-B coverage in the traffic pattern. At Sporty's, for example, just east of Cincinnati, Ohio, we get ADS-B reception 200 feet after takeoff. The even better news here is at 5,000 feet. So let's talk about maybe a little more typical cruise altitude. You can see you have coverage basically everywhere other than the most rugged mountainous areas out west. And if you know that terrain, 5,000 feet AGL is maybe 20,000 feet in some of those places. So ADS-B coverage has gotten very, very good. So that's less of an issue now. And of course, the major benefit with ADS-B is it's subscription free. I won't say it's necessarily free because your tax dollars did pay for the construction of this, but there is no monthly fee for the weather. So you can just turn on an ADS-B receiver and start receiving the weather. So what do you receive with ADS-B? Well, I would say all of the essential things, certainly not a full menu as we'll cover here in a second, but all of the essentials. Radar, number one there. Airmets, SIGMETs, METARs, TAFs, PIREPs, winds and temps aloft. So all the things you really need to make those weather decisions. The other question we get a lot is, well, how often is it updated? The number one thing to understand about any data link weather product, whether it's SiriusXM or ADS-B, no matter who you get it from, whether you have a Garmin or a Stratus or an SXAR1, there is no such thing as real-time data link weather. It is all delayed. So none of this stuff is real-time. Now, having said that, it is updated regularly, and it's pretty fresh data. So you can see here the regional radar with ADS-B weather, which is radar going to be within about 150 to 250 miles of your airplane, is updated, the image itself every 5 minutes, and they retransmit it every 2.5 minutes. So in general, the radar I see is in the 5 to 10 minute old range. So it's not real time. It's not for picking around embedded thunderstorms, but it's certainly up to date enough to give you a really good sense of the big weather picture. You can see there's a few variations there in terms of other weather products and how often they're transmitted. But in general, every 5 to 10 minutes, you're getting fresh weather. One more detail on ADS-B, it is a network of ground stations, as I mentioned, and it's a little different in that, I guess, again, it's like VORs. There are different types of ADS-B ground stations. There are surface, low altitude, medium altitude, and high altitude stations. And this does not really matter in everyday real-world flying because at cruise altitude, you're going to have 7, 8, 10 stations. And so you don't really care whether you're getting surface or medium or high. The only reason I point this out is that these stations do transmit different weather data. So you could be in a situation, maybe right after takeoff, you're at low altitude, and it's possible you're not getting the national radar picture. And every once in a while, I'll get a pilot email me about this and say, hey, I had radar within about 150 miles of me, but I didn't see any radar beyond that. Well, in that case, what probably happened is you were receiving one single station and it was a low altitude station. And so you were not getting that what we call CONUS, continental U.S. radar, because you need a medium or high altitude station to get that. So again, this is not something to get bogged down in everyday life. You really don't need to worry about it. Just something to tuck away that if you ever feel like you're not getting all the weather data from ADS-B that you expect, look at the number of stations you're receiving from, because it could be a function of this different type of stations that are scattered all across the U.S. Okay, so that's ADS-B. It's subscription free. It's from the ground up. SiriusXM is kind of the other way around. So you might say this is the GPS option. SiriusXM is satellite based. It's transmitted from a geostationary satellite above the North America. So that means it works at all altitudes, even on the ground. You can be sitting on the ramp with the engine running and be pulling in coverage with SiriusXM. It also does offer coverage in southern Canada and northern Mexico, and a little bit out into the Bahamas. So you've got a little bit of coverage further north and south than you will with ADS-B. And importantly, when we talk about coverage, you have to both be able to receive the data and also have the right data to receive. For example, ADS-B can be received over the border in Canada if you're at altitude. I've been flying into Toronto, and at 9,000 feet, you can still be receiving some U.S. ground stations. And that's good, but what you run into is the radar transmitted is only U.S. radar. So you need that Canadian radar if you really want to go too far over the border. And as we'll talk about here in a second, SiriusXM does offer Canadian radar in addition to U.S. So the other big difference with SiriusXM, it's satellite-based, and as a function of that, really, it requires a monthly subscription. So you're going to pay anywhere from about $30 to $100 a month, depending on the weather products you want. One of the things you get with SiriusXM is more weather products. So here's an example. Scott talked about base and composite radar. And for most pilots, composite is kind of the default. It's the worst case scenario. So you want to know the worst possible return in a cell. Well, SiriusXM offers both. So you can see base and composite side by side there. The composite looks a little bit worse. But that lets you compare if you want to try to get a better idea of what's really coming out the bottom of that cloud. Maybe you can do that. There are also storm cells, so you can see the height and direction of travel of a storm cell. You get satellite imagery, which you do not get on ADS-B. You get lightning and turbulence and icing forecasts, which we'll talk a little bit about later. So you do pay a monthly subscription, but you do get more options for more weather products. Here's maybe a good summary of ADS-B versus SiriusXM and what you get on both. So again, all the key weather products you get on both. The only ones to point out really, I think, are lightning is not available on ADS-B, and you do get it with XM. And then satellite imagery is not available on ADS-B. It's worth pointing out here that may change. The FAA has talked about adding satellite imagery and lightning and some other weather products. That's supposed to be coming in the next 12 months, but you know how that goes, so I wouldn't exactly set your watch by that. But these things are not fixed. ADS-B should be adding some products. The folks at SiriusXM are also always thinking about adding products, so this is dynamic. One other thing that comes up with SiriusXM is you may say, well, you may have heard someone say, well, ADS-B radar is blocky and low resolution and SiriusXM is higher resolution. Well, not really. Here we're comparing ADS-B regional radar, so that radar within 150 to 250 miles of your airplane, with SiriusXM, and it's the same app. These are both ForeFlight, and you can see really the resolution is the same. When you zoom in close, it gets a little blocky. The difference here is that SiriusXM offers that higher resolution radar all across the country. There's only one resolution of SiriusXM radar, whereas ADS-B, as I mentioned, you get beyond that 150 to 250 miles, and that's when things start to get a little blockier. That CONUS, or that national radar picture, is a blockier image. So that's usually what people are talking about. But within 150 to 250 miles of your airplane, you'll see the same resolution. The only other thing I'll point out here is, in my experience flying with ADS-B now for 6-7 years, it's not a functional difference, I don't find. Red is red, and you're probably going to avoid it. There's no amount of resolution that's going to make a nasty squall line out in front of a cold front look good. So I wouldn't get too hung up on that. Higher resolution is better, and you can take it. But in this example, that weather up ahead of us is a good, I think, 500 miles out in front of us. So having that high resolution is nice, but certainly not a must-have. Okay, real quickly, we'll talk about the hardware options, the ADS-B options, and then the SiriusXM options, and then I'm going to pass it back to Scott. So if you're in the market for ADS-B receiver, the good news is there are many options. I couldn't possibly cover them all. I'll just highlight a few of the ones that are most popular here. Stratus 1S and 2S, those have been the most popular for the last couple years. Stratus 2S in particular. That's on the right of the screen there, and this is really your all-in-one. So it's ADS-B weather. It also has GPS for moving map. It has AHRS for backup attitude. It has a dual band traffic receiver. It has a flight data recorder. Pressure altitude sensor, you name it, it has it. It's all wireless. It has an 8-hour battery built in. So that's really the top of the line, get it all option. And that works with ForeFlight. If you want something a little more basic and you just want to get weather, there's the Scout, which is also available for ForeFlight. That's only $199. Gets ADS-B weather and dual band traffic. So it's a great value there for under $200 and no subscriptions. That is the probably the best way to get started with weather on a budget with ForeFlight. There's no GPS there and there's no battery there, so there are some limitations you want to be aware of with Scout, but again, the price is right. If you're flying with WingX or Flight Plan Go or FlyQ, there are lots of other options. Two great ones are the Dual XGPS 170D and the Dual XGPS 190. One is basically weather and GPS and traffic. The other adds AHRS for attitude. And if you're flying with Garmin, they have the GDL50, which was just announced, and this is a follow-on to their GDL39. Same idea as a Stratus. It's got a built-in GPS, AHRS, dual band traffic receiver, weather, has an 8-hour battery, sits on your dash, has a little pop-up antenna. So there is an option for really almost any app that you're flying with. When it comes to SiriusXM, not as many options, but again, the two main apps that we see most people flying with are covered. With ForeFlight, that'd be the SXAR1, that little white box there. $599 has GPS and weather. No traffic here because you don't have the ADS-B. And then if you're flying with Garmin Pilot app or with Garmin GPSs like an Aero 660 or an Aero 796, that'd be the GDL51, which you see on the right there. Same idea, GPS, built-in battery, SiriusXM. Two things worth pointing out in SiriusXM, you can also get radio. So for your passengers on a long flight, you can get those SiriusXM music stations, which are kind of nice. You can Bluetooth that to a Bose headset, say. And that's nice on a long trip. I've actually found I enjoy that more than I thought I might have at first. And then also, SiriusXM is offering through the end of this year a $200 rebate on both those. So that makes those pretty affordable options. And then finally, if you want to have it all, if you're the type of pilot that just has to have everything, Garmin has recently introduced the GDL52, and this is everything. SiriusXM weather and radio, dual band ADS-B traffic, ADS-B weather, GPS, AHRS. It has a 5-hour battery. So this is everything. You can pick and choose which weather you want. Or I think, as a lot of people do, you can fly with SiriusXM weather, but then still have ADS-B there for traffic. It's a little expensive at $1149, but again, it's the most complete option out there, and that $200 rebate still applies. So if you'd rather not choose, GDL52 is the way to go. Again, works with Garmin Pilot app, which is available for iOS and Android, and it also works with Garmin GPSs like the Aero 660 and the 796. Okay. Now we have that background, I'm going to turn it back over to Scott, and we're going to start applying some of this knowledge to what we actually do in the cockpit. So stand by 1 second, and here comes Scott.
Thanks, John. As we prepare for our next section here, just want to give you an overview of what we'll be covering. So we've already talked about radar, but now we're going to talk about specific shapes and traps that you might find yourself in. We want to make sure that you're up to speed on using satellite for icing. Plus, we'll talk more about METARs and interpreting METARs. I'll give you a complex case. If you're the person that usually trails off once you see the letters R, M, K, you might be surprised for what you might find on your runway in the example coming up. Let's talk about some general thunderstorm types. And there are 3 buckets that most thunderstorms fall into. You have a single cell storm, usually the lone wolf, usually benign, lasting about 30 to 60 minutes, although new storms may develop on the leading edge, the advancing front of a single cell storm. Same with the other thunderstorm types. And typically we find these single cell storms in weak or weaker wind shear. That's not always the case. Sometimes we can get a single individual thunderstorm that packs a bigger punch, but And a day where we have relatively weak wind shear, which we'll discuss more in a moment, we're looking at single cell pop-up storms that last about 30 to 60 minutes. Multi-cell thunderstorms, more on the left side of this radar picture. That's where we find the more elevated hazards, perhaps some hail, perhaps some lightning, perhaps some strong or damaging winds. Those too can last about 30 to 60 minutes, perhaps a little longer. And we usually find those in a higher wind shear environment. Shear more supportive of organized thunderstorms. And then we have the bad boys, supercell thunderstorms that are typically rotating. They're typically tilted, indicating they're in a higher shear environment. That's also a high hazard environment. These are the thunderstorms that typically bounce all the way up to the top of the troposphere and try and extend into the stratosphere with overshooting tops going all the way up to 50, 55, or 60,000 feet. You'll want to avoid those. Here are some radar signatures to avoid. And again, these are cases that I have extracted from weather's past. You might find storms or lines of storms that look a little different, but generally you want to avoid bowing lines of thunderstorms where you have a strong low-level jet. If you're looking at your winds aloft and you see winds screaming at 5,000 feet or 850 millibars straight out of the west in a thunderstorm environment, look out, because there's usually a strong to damaging wind threat there, widespread enough to probably keep you on the ground. Supercells usually have a kidney bean shape, some kind of curve, some sort of hook echo, appendage sticking out of the main part of the thunderstorm. All hazards are there, including tornadoes, large hail, downbursts, all hazards to your aircraft. But also more generically, you'll want to look for rapidly developing thunderstorms, thunderstorms that suddenly turn from nothing or a lighter color on your radar display to explosive red, white, or magenta. Those typically have large, rapid vertical development, and you can get all sorts of hazards with those. It's worth noting that radar's not all made the same. It depends on the source of the radar imagery. If you look at the image on your left, this is a comparison of internet, ADS-B, and SiriusXM colors. Notice that green is not necessarily green, orange is not necessarily orange, and yellow is not necessarily yellow. A cell of moderate intensity may be a deeper green or maybe a yellow, depending on what product you're looking at. So make sure that you understand what product you're looking at and the differences between radar intensities and what colors those mean. Now, more recently, you can, in apps like ForeFlight, get a 4-color radar. But if you compare the color table at the right to that of the left, you might find that intense storms, 50 dBz specifically or higher, tend to run a little hot or more intense than they perhaps actually are. But this is an option that you can find under the map settings if you're using ForeFlight. Plus, these are only 2 sets of colors. You have additional colors for winter mosaics. The takeaway here, not all radar color tables are made the same. Make sure that you're familiar with the differences between SiriusXM, ADS-B, internet color tables, the 4 color tables. Plus, as we get into the color season, you've got to pay attention to those as well. A very important point here is assessing wind shear and atmospheric stability. When we're talking about wind shear, we're talking about 2 different components of wind shear. You have speed shear, which is an increasing speed of the wind with increasing altitude. And then you have directional shear, which is the direction changing with increasing altitude. A straight line wind threat is usually found with higher speed shear. That means that the wind near the ground is weaker than that of the wind aloft, and is generally out of one direction. If you have a strong westerly wind from the ground all the way up to 30,000 feet and speed shear is high, you're most likely looking at a damaging straight line wind threat, a bowing line of storms. The rotating storm threat becomes higher when you have higher directional shear. Now, worth noting, the direction of the wind near the ground, let's say it's out of the southeast, is typically much different in a high directional shear environment then it is aloft, and it's typically out of the west. So you should be looking for, when you're going through your winds aloft panels, the speed and the magnitude of the wind, but also the direction of the wind. And that will give you the best insight possible as to what types of thunderstorms you might experience. Generally speaking, for atmospheric stability, if you're wanting instability, you want warm, moist air near the ground. You want cool, dry air aloft. You want high shear, both speed and directional shear, one or the other, because that will typically support more organized storms. If you have cool, dry air near the ground, you're typically looking at a more stable air mass. Looking at the temperature and the dew point and winds aloft can tell you a lot about what type of weather you're going to expect. That's the takeaway from this slide. Let's talk a little bit about icing. And again, if you have ForeFlight and a SiriusXM package, make sure you know what you're getting. I believe there are 4 different tiers of SiriusXM weather for ForeFlight. So this imagery is likely in the higher tiers. Make sure that your plan, if you want icing information, includes this. We're typically looking for the yellow and green colors if you're using ForeFlight's color IR imagery. That's where the highest risk for in-flight icing is. However, there is a big caveat here, and that is high-level clouds can mask the lower level icing threat. A good example of that is here. We can't see the yellow and green colors, even though they would be there, but we had high-level clouds that are showing up in blue. Now, it's worth noting we can still get icing in the upper levels, but we typically find more ice crystals as opposed to super cooled water. So the takeaway here is that the icing imagery and the color IR imagery are very important for assessing an icing threat, with that important caveat of high-level clouds possibly masking the lower-level icing threat. So imagery is great, but make sure that you're using this in combination with PIREPs, air mats, and other information, including METARs, to help you make the right decisions as a pilot. Imagery is great, forecast products are great, but ultimately it is up to you, the pilot, to keep you and your passengers safe. There are some differences in the icing products. Icing US is a product based on the WRAP model. That is a short-range model that typically goes out 18 hours. It's higher resolution, and the model updates hourly. That is different in ForeFlight than the icing global product, which is based on the GFS model. That's a longer-range model. It's a lower resolution model. That model updates 4 times each day, 12, 6, 0, and 18Z. And it goes out to 24 hours. It's important to know that these are computer forecasts, so it's essential, just like we discussed with icing products and satellite imagery, to compare them with PIREPs, air mats, and other surface reports. Also note, the colors tell you not a likelihood for icing, but the amount of time that it will take for a given altitude and a given time to get a 1/4 inch of ice accretion. So in this example at the right, that deepest shade of blue, 5 minutes or less to pick up a 1/4 inch of icing. And that threat goes down. The time to icing goes down as you get into the shades of white and the lighter shades of blue. Lastly, we'll touch on METARs here. I'm sure you're familiar with those if you're an experienced pilot. You should be fluent in how to speak and read METARs, but you should also know the common misconceptions. One trick that I learned from John a long time ago, fog with a visibility over 5/8 of a mile is reported as mist, or BR. Make sure that you're looking for runway visual ranges specific to a runway. Know that V in METAR groups can indicate conditions varying, and be familiar with the sequence of a METAR. We talked about this earlier, to know when data are omitted. But let's take this one step further. Being a weather geek pays dividends. Let me give you an example of this. This was a METAR from a couple months ago at the Cincinnati Northern Kentucky International Airport. If you're typically the person that reads a METAR string and you stop when you see RMK, you see light snow is falling. The temperature is 3 degrees Celsius or 27. But if we actually take the time to go through the entire METAR, we find some additional hazards. If we look at the freezing drizzle ended 51, we find that that was just a minute ago. Now, the I group indicates that we haven't had any accumulation in the last hour. That's for the I1 group. But if we look at the I6, that actually indicates that we had 0.14 of an inch of ice accumulation in the last 6 hours. So despite light snow falling at the time of the observation and a temperature below freezing, that's actually not our biggest concern. It may be the freezing drizzle and the 0.14 of an inch of ice that has accumulated in the last 6 hours that may be a problem. So in this case, especially with a low overcast at flight level, or I should say 1,100 feet, that runway is likely still icy. And until those clouds break, it's likely to stay that way. So you should be doing your best to go beyond the basics of a METAR and what ForeFlight automatically breaks out for you, and actually look at the METAR string. Worth noting, this is a 12Z METAR, which is typically more comprehensive. 12Z, 6Z, 0Z, and 18Z METARs typically have more information at major airports. So make sure you're spending your time understanding not just the basics of a METAR, but with time, the more advanced things. Now let's take this more complex weather theory and test it all. Let's send things back to John.
All right, thanks, Scott. Really good. I love that METAR one because I'm so guilty of that. I get to RMK and think, well, this is all just the fluff, and I can stop reading. So that's a great reminder. What we're going to do now is jump into some application of this stuff, some of the theories, some of the products, and I'm going to show you 4 scenarios of flights I have flown in the last couple of years and how I have used datalink weather, excuse me, both SiriusXM and ADS-B to make some weather decisions. Most of them good, a couple of them I'm not proud of, but this is the fun stuff to me. Weather flying really is a mental sport, and so putting this stuff into practice is really a fun part of flying. Here's the first one. This was a trip last fall, headed out west from Cincinnati area, and it was just a nasty looking day on the radar. You can see the red line there is my intended route, and there are just multiple lines of ugly stuff. This is on ADS-B here in ForeFlight. And so, your first reaction might be, well, no way, forget it. We're not going anywhere with that. And that was my first reaction. But then I thought, I have all day to get to my destination. I'm up for a challenge. I like this stuff. I have pilots on board. And so I took another look at it, and we ended up making it just fine. You'll notice we did not go direct. We didn't go anywhere close to direct. But we took what Mother Nature gave us, and it ended up being a pretty good flight. We had a couple of bumps going around the north side of that weather, but really not bad at all, and actually stayed in VMC conditions for most of the flight, which is how I like to do it. So this is just an example to me of how datalink weather has changed how I fly. It's no longer go straight, fly up to the weather, and hope you can pick your way through it. You take a look at it, and you'd see what Mother Nature's given you, and you work with it. And I will plan deviations way ahead of time. In this case, we just changed our whole flight plan, and we just filed a totally different flight plan and told ATC from the very beginning, hey, we're trying to avoid all this weather, and so we don't want any shortcuts. We want to go this long route all the way around the top, and it worked out fine. It's another example here. I pulled up Garmin Pilot with XM weather, SiriusXM weather on it. A day like that where it's really ugly, it's all about using all the tools, and I'll show another example of this later. But sometimes, as pilots, we kind of get locked into just looking at the radar, and well, what's the radar look like here? That's important, and certainly radar is the most important thing we're going to look at. But there's lots of other pieces to it. You can see here storms track, the storm cells, the satellite. All of those pieces came into play on this trip, PIREPs in particular. So don't get caught just looking at the radar. So here, my lesson for this first one is go around the weather. As it says, resist the temptation to use datalink weather as a tactical tool. It's not. You should not be picking around closely spaced thunderstorms with datalink, no matter what it's from. The idea is to give you the big picture view and to help you make big deviations before you get close to it. That is really the key mindset when you're flying with datalink weather, is make the big strategic deviation 100 miles before you get to the weather. You'll be shocked at how little time this adds to your flights, by the way. I'll sometimes do one of these flights and feel like I deviated all over North America, and you get home and realize it costs you, 17 minutes on a 3.5-hour flight. So I've learned to be pretty comfortable making these big deviations. Here's the second one. Coming back from the West Coast towards Cincinnati. Pretty ugly line you can see here. Pretty lit up, lots of colors here, and but it looks like everything's going to work out, right? Because in the Midwest, weather always moves from west to east, so that's going to slide on out. Just as we get there, we'll touch down right after the rain ends, and life will be good. Well, certainly none of you are as dumb as I was, because that is not what happened. The weather this day was actually kind of drifting south. This was not frontal weather. It was just kind of an air mass cell that was just kind of sitting there and building up and raining itself out and building up and raining itself out. So we got ever so close to our destination, but looked out the window and could tell quite clearly we were not going to make it to the airport we wanted to. So we turned around and landed short. And it's just a reminder to check your assumptions. In this case, I definitely should have animated the radar. All of these apps, there's a play button in the bottom of the screen there that lets you animate the radar so it moves. And that's obvious, but we tend to forget it a lot. But even just beyond animating the radar, check your assumptions. If you assume here, as I did, weather moves west to east. Well, are you sure? Do you know that? Or another example would be, well, yellow is always bad on the radar. What? Are you sure? It depends whether it's a stable or an unstable air mass. If it's convective, yellow is probably a bad deal. If it's a weak warm front and it's not convective weather and it's just rain, you can fly through moderate rain all day long with hardly a bump. So, good reminder to make sure you think about what are the assumptions you're making about the weather picture you're looking at. Here's another one. This was from last fall as well, kind of on the back side of a really fast-moving and pretty ugly cold front, one of those days where the temperature drops, 25 degrees in a couple of hours. This is a great example here where it really wasn't about thunderstorms. That wasn't the problem, and this was IFR, so I really wasn't that concerned about ceilings of visibility. They were good enough. The concern here is icing. I don't know any pilot that likes icing. And so winter day like this, post-cold front, icing a real concern. And here's where radar is not enough. You really have to use all the tools at your disposal. In this case, this is pre-flight actually, the icing tool, but you can get this with SiriusXM as well. And it gives you, again, this is a forecast. So as Scott said, this is a model-based forecast, this icing. So you don't want to take this as absolute truth. But I've found, especially the last couple of years, these icing forecasts are very, very good. They've gotten better, I think. And so you use a combination of the slider on the right side for altitude and the slider on the bottom for the time, for the forecast period. And it really gives you this 3D, I guess 4D view almost with the forecast in the future, what those icing conditions are like. And then again, here's in-flight. We marry what we saw there with the icing forecast with all the tools. So here's an example where, on most flights, I don't care a whole lot about satellite, to be honest with you, because, that's not the most important thing. Here's one where satellite really paid off. You can see the brighter white clouds there, the higher tops, and then you can see to the west of that towards our destination in Nashville, where it's the darker clouds. Those are the lower cloud tops. That gave me a really good idea that the thickest clouds were moving out. Then I combined that with pilot reports and METARs. And all of that goes together to give you that picture of the atmosphere you're flying in. So the lesson here is use all the information. Don't get locked into just looking at radar or METARs. Look at all the information, put it together. Look at your route. Look at the METARs. Look at the temperature on the ground. Are you going to be out of icing when you break out on the approach? What are the PIREPs saying? Are there a lot of them? Are there none of them? What kind of airplanes are reporting icing? What altitudes? Use that with the forecast. You really have to put all of those together. You can't just focus on one weather product. You can get into trouble. All right, here's the last one, and maybe the easiest, maybe the most important as well. Another trip coming home. That's always when the bad weather happens. It's coming home when it's late on a Sunday night. Here it looks pretty good though. We've got Stratus running on ForeFlight here, and looks like, boy, there's plenty of ugly weather. This is summertime in the Midwest, so thunderstorms come up like this. But you know what? We're on the north side of it, and looks like we're going to scoot around the edge of it pretty well. We're getting closer here, almost home, and look at that radar. It's just like the, Moses parting the waters here. I mean, here we are. We've got this great gap. Looks good, right? What's wrong? That was what the gap looked like out the front windshield. There's a gap. You can see blue sky there, but would anybody like to fly under that towering massive cloud there? You might make it through, but you probably get a little jolt, and you might get something a lot worse. And so the point here is your eyes always win. Very basic, but I think often forgotten, that as Scott said, these tools here can help inform your decision. They can give you important data, but they cannot make the decision for you. The decision rests with you. And the most important weather sensor you have is the Mark I eyeball that is sitting in the left seat looking out the front window. If it looks ugly, don't fly through it, no matter what you see on the screen in front of you. I have flown through yellow and red radar because the cloud out front was a 4,000 foot top that was flat topped and stratus clouds in a stable environment. I have also deviated around plenty of clouds that didn't show up anything on the radar because they were white and cumulus and billowing tops, and you could tell that the ride was going to be bad. So your eyes always win. If you want to put this in maybe a more of an idea of how to make these weather decisions in a flow, this is really how I think about it. You have to start with the big picture knowledge. You can't just look at the symptoms of a disease. You have to have sort of a theory here, right? So I like to come up with a theory. Where are the highs and lows? Where are the fronts? What is the big weather picture that this is all fitting into? And then once you have that context, you can put the datalink weather piece into it. As I said, yellow can be bad, yellow can be not so bad. If I know the big weather picture, if I know that I'm in a cold front with a lot of convective activity, okay, well, yellow takes on a whole nother meaning on the radar. And then finally, you check that with the eyes. This is kind of how I think about it. All of these things come together in a funnel. If I know the big picture environment, if I know the air mass I'm flying in, if I back that up with some data from Datalink Weather, and then I confirm that with the view out the front of the cockpit, that's how you make smart weather decisions. All right, so we're going to wrap up here and then save some time for questions, so feel free to put those in. There are clearly more than 4 tips to flying safely in weather, but I think these are probably the most important ones. I just mentioned, start with the big picture. It's easy to overlook this. It's easy to look at your METAR and say, okay, well, the METAR is good and the radar doesn't look bad, we're out of here. That's not enough. You really need to stop and look at those highs and lows. Look at that weather depiction. Look at the prog charts. Understand the big picture. Make kind of your own forecast. Second, when flying with Datalink Weather, very important to always look at the timestamp. Every app, every device you look at will have a timestamp showing when you receive the weather product. Here's an example in ForeFlight. You can tap on that timestamp in the top left corner and see when all of those weather products were updated. Now, it's worth noting that if it says 11:15 a.m., that radar picture may have the radar may have swept the sky at 11:10. And 11:15 is when you received it. So that doesn't necessarily mean that the weather is, 1 minute old. The reason you watch that is you want to make sure that you continue to get updated weather. So if you ever see that get to 25 or 30 minutes from your last update, you have a problem. Your receiver has gone bad, the battery ran out, the connection to the iPad quit, something. So keep a sharp eye on that timestamp. That is important. The third one is, as I mentioned in that third scenario and the first one, use the information in context. No tools fly for free here. You use it all. So if you've got METARs and PIREPs and AirMets and SIGMETs and radar, use it all so that you get that complete picture of the 3D environment. Don't just get locked into one picture. And then again, the eyes. Can't stress it enough. Your view out the cockpit is what matters. This is especially important when talking to air traffic control. Air traffic control is great, and they have really better weather tools now than they had just a few years ago. So ATC is another great asset to use when you're flying around weather. However, ATC is sitting in a very nice, comfortable chair in a dark room on the ground. They are not sitting in the cockpit looking at the clouds or the wind or the rain that you see out the window. So you cannot outsource your decision making to ATC or anyone else. That rests with you. And again, your eyes are the best judge there. If you see something that doesn't look good, don't do it. Don't let a weather product talk you into something that your gut is not comfortable with. All right, with that, we're going to wrap up here. We've got some questions here I'll sort through here. And if something occurs to you afterwards, please feel free. Our email addresses are up there, and would love to answer questions afterwards. But Scott, I'm going to start out through a question to you because we've got some good kind of weather geek questions, and I want to get your perspective here as a meteorologist. One question came in on SCU-T log P data, and are those, I guess, real quick for those who don't know, what is that, and what are they really saying in a SCU-T log P, and what can you get from that diagram?
Well, SCU-T log P is a meteorologist's best friend. I always think that some of the best meteorologists I know are looking to see what is actually going on instead of just jumping into the model data. But when they look at the model data, they're looking to see, using a SCU-T log P, how the temperature and the dew point will change with increasing altitude. And we're looking at a SCU-T log P, we're focused on a specific point. So there's the observed SCU-T log P, which comes from a weather balloon released typically twice a day at various spots around the country. And that will give you a vertical profile of the temperature and the dew point. And then you have forecast SCU-T log Ps, which can be very helpful for assessing the stability of the atmosphere. Plus, as part of the SCU-T log P, it's not just a skew of the temperature and a logarithmic scale of the pressure, plus the dew point thrown on there. You're also getting the wind. So we talked about stability and we talked about wind shear. Great tool for looking at the change in the wind speed and the wind direction with increasing altitude, but also looking at the change in the temperature and the dew point aloft. And in Sporty's private pilot course, we talk a lot about stability, and we actually go through lapse rates and what will happen to a parcel of air as it cools, and whether that parcel of air will continue to rise or it'll fall or will level off. That's very important to a meteorologist for determining whether or not there are going to be explosive thunderstorms or it's going to be a fairly quiet day. Some things to look for in a SCU-T log P is the temperature and the dew point very high, close to the ground. Do we find cool, dry air aloft, meaning the lapse rate, the rate at which the temperature and the dew point fall with increasing altitude goes down? That will typically support instability or more explosive thunderstorm development or convection. If we see hints like an inversion, an increase in the temperature with increasing altitude, that's typically apparent in a SCU-T log P. So looking at the profile of the temperature, the dew point, and the wind over a spot over time is very important. If you live near a major city, there's probably a SCU-T log P, a weather balloon that is launched early in the morning, typically 0Z, or 12Z early in the morning, 0Z at night. In more active weather situations, 18-6Z weather balloon launches, SCU-T log Ps may be produced. And that will give you a good snapshot of how stable or unstable the atmosphere is, but it will also give you a indication of how the wind is changing, both the speed and the direction with increasing altitude. I think it's a very important tool, and I would love to see more of this information available in weather apps. That may be something to add in the future.
Yeah, I'll just echo from a pilot standpoint. It can look a little intimidating, but once you learn to read some of those signatures there, I do think it's helpful for finding cloud tops, freezing rain potential, the thickness of cloud decks. You can get carried away. You don't want to read too much into it, but it can be directional, I think. And in terms of finding it, there are some apps out there that are either free or very inexpensive that collect those SCU-Ts. You can also find them online free from many government sources. So if you just Google SCU-T, you can find a bunch of different options for them. Question here that I'm going to answer part of, and then Scott, ask you a little bit about. And the question is, I think, a great one, which is cloud tops. How do I find cloud tops? And Boy, for me, that is such an important question that I'm not sure enough. I'm not sure ATC or even some meteorologists understand how important that is, especially in a piston airplane. Getting on top in the wintertime can be the difference between being out of the ice and being stuck in it. It can be the difference between a terrible ride and a good ride on top. So it's really important. Finding that information is not really easy. The old area forecast used to be the only place you could really find cloud top forecasts. That's now been replaced by the graphical forecast tool at aviationweather.gov. I find, frankly, that tool isn't great for cloud tops. It really, in particular, does a bad job with convective weather. It really doesn't forecast those properly. So they're working on that, but that one's not great yet. The best answer for me on finding cloud tops is PyReps. And just reading those PyReps. If you are flying, ask ATC. A lot of times ATC will have cloud top reports that don't get passed through as a PyRep, so they don't show up on ADS-B or SiriusXM or on your app. You've got to ask for them. But really, PyReps are the best way. And Scott, the part I'll throw to you is we had somebody ask about what about ruck soundings for cloud tops? And I guess that's related to the SCUT, but how much stock do you put in that? I mean, can you really, you think, determine a cloud top off a sounding, or is that sort of a trap?
I actually think that this leads back into something that we did, I believe, for the Takeoff app, talking about the cloud top tool. And you and I were talking about it as we were assembling it, saying this is not a strong tool. And it's worth noting that that cloud top tool is not a human forecast. It is a computer forecast. I heard the RUC thrown around. That is a short-term forecast model. That was the predecessor to the RAP. And now the high-resolution RAP, or rapid refresh, is coming out. And again, these are short-term models that update every hour with the best available information, if you will, with some quality controls applied. It's difficult. Admittedly, it is difficult. You can use radar to determine the cloud tops, or at least the thunderstorm top, but that's different than the cloud tops. A lot of it can come back to something like a SCUT. If you're looking at different model outputs and you start to see, as you were mentioning, a very close temperature and dew point up to a specific altitude, and then the temperature and dew point starts separating, you might think of that as a good starting point for where my cloud top may be. But all bets are off in a thunderstorm environment. If you have a lot of shear, a lot of instability, the low, mid, high levels of the atmosphere are very unstable, you can easily get thunderstorm tops that exceed beyond what you're thinking. And worth noting, I think even the cloud top tool will max out at 40,000 feet. Obviously, you're going to get thunderstorm heads taller than that in highly convective, highly unstable, highly sheared environments. I wish there were better tools out there. I would just encourage all pilots to take that guidance with a big grain of salt and know that even meteorologists are struggling with that. But if you start looking at SCUTs, if you start looking at the cloud top tool, just like any tool, you start to see a bias over time. And like you said, PyReps are, I mean, it's a pilot report. That's as good as it gets. And if you're asking for additional information, that's a great start. But I would use the tools that you have and start seeing if you can find a bias for your particular region in how good those tools are.
Yeah, and I'll mention, Scott, SiriusXM does have a cloud top product that is available. I find it's useful, but it's only sort of directional. So it will tell you where the tops are higher or lower relatively. It should not be used to say, well, this top is 8,000 and this top is 10,000. There's not really that level of precision at all. And they don't even claim that. But it's just something to be aware of. If you're flying with SiriusXM, cloud top tool is available with some of those subscription packages, I think on the $55 and up packages. And it's helpful, but again, don't read too much into it. It's really only for where is something really a billowing high top and where is something really maybe low stratus. You can't go much beyond that. I'm going to go with one more question here for you, Scott, and then we'll wrap up. The reminder, this webinar is being recorded, so you'll be able to find it at sporties.com/webinars. You'll also be on YouTube, so you can watch the entire recording if you missed something. But Scott, question going back here to radar, and the question was, what's the effective range of weather radar? And are there limitations with the radar product that we're getting beamed up into the cockpit that we should be aware of?
Yes, I think so. I think there are limitations for every radar. It's a tricky situation because vendors love to massage data. They love to quality control the data so that you have a clear focus on what is important. I think once you start to get about 150 nautical miles out, you're really losing a lot of the low-level radar data that you need that, frankly, a lot of 10,000 feet and under pilots are flying in. Now, thankfully, we have radar mosaics, but as you said, that's kind of a worst-case scenario. It is the composite of all the composite radars. So it depends. We're not in an era where you can target a specific radar in flight. So your best tools are going to be base reflectivity, which is more or less just the, I believe the base reflectivity mosaic is just a stitching of all the lowest level base reflectivity scans. And then the mosaic that we know and love for the last 15, 20, 25 years is all about composite reflectivity. So there are limitations to radar. And a lot of them have to do with, especially as you get into the mountainous west, radar is not an effective tool just given the terrain changes. But even as you get away from major metropolitan areas where there's not a National Weather Service or an FAA radar that's going into the master feed of ADS-B or SiriusXM, you lose a lot of that low-level advantage. So I would just encourage everyone that uses radar data to know that radars do not scan at the ground. We all know as pilots and as meteorologists that there's a curvature to the earth and that the radar does not scan at an elevation angle of 0 degrees. It's typically 0.5 degrees, if not higher. So with increasing distance from the radar, you're looking higher up in a storm for a given radar, and that can impact the composite. So, like I've said all along, you should be aware of those low-level radar limitations. Know that your eye looking out of the cockpit is a far more important tool and should always have that veto power. And know that radar technology will only get better as our government invests in it. We've done a lot to clean up the radar in a lot of these vendor displays compared to several years ago. And radar resolution has come up in the last 10 years, but keep in mind, you're looking at different levels of a storm depending on which radar you're using.
Great. Thanks, Scott. And thanks for joining us tonight. Really great to have the expertise of a meteorologist here. Thanks also to everybody who joined us out there on this webinar. I'll give you 3 resources if you really want to dive into more weather here as we wrap up. Number 1, again, sporties.com/webinars, or check out Sporties on YouTube. You can find a recording of this webinar in a couple days, in addition to some other great weather webinars. Also, airfaxjournal.com. Airfax is an online magazine we've been doing for 6 or 7 years now, and we spend a lot of time there talking about weather and weather flying and weather scenarios, and that's totally free, so I invite you to check that out. And then again, Sporty's Takeoff app. This is an app where we post multiple articles, videos, quizzes every day, including some of those Weather Geek segments with Scott Dimmick. So if you really want to learn the ins and outs of weather and go beyond the textbook answer, I invite you to check out sporties.com/takeoff and download that app. For now, well, thank you for joining us and hope to see you again on another Sporties webinar in the future. Thanks.